Hi everybody, I'm Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory, and this is the monthly update from March 1st of 2023, the birthday of Yellowstone National Park. I thought today we might address one of the more common questions we get here at YVO, and that's whether or not an external event could ever trigger a Yellowstone eruption. For example, a distant earthquake. This is a question we got quite a lot in 2019, after the magnitude 7.1 Ridgequest earthquake in eastern California, and again in March of 2020, when there was that magnitude 6.5 in central Idaho. More recently, we've been getting that question quite a bit about whether or not a nuclear blast could trigger a Yellowstone eruption. And the answer to all these questions is no. That's not the way volcanoes work. In order to be triggered by some sort of external event, a volcano would have to be basically about to erupt anyway. And most of that eruptive pressure comes internally from the exsolution of gases, sort of like shaking a soda and having all those bubbles come out. That's what drives eruptive activity. And external events just can't cause that. So eruptions being triggered by earthquakes is extremely rare. You can see this in Yellowstone's history. The last lava flow eruption was 70,000 years ago, and there have been hundreds to thousands of magnitude 7, 8, 9 earthquakes in the western US since that time. The last big explosion, 631,000 years ago. There would have been thousands of very large earthquakes in the western US since that time, none of which triggered eruptions. The same goes for a nuclear blast. Most of that energy is actually going into the atmosphere. Even if an impact were to occur and drive a weapon into the ground, we're still talking 3 miles to the magma chamber. And so a lot of that energy goes up instead of into the surrounding rock. And perhaps the greatest evidence that this doesn't work is looking back at the 1959 earthquake. There was a magnitude 7.3 that occurred just west of the park near Hebgen Lake. This occurred several miles deep, essentially right next to the magma chamber, and it released the same amount of energy as a moderate-sized nuclear weapon. And of course, nothing happened in terms of Yellowstone eruptive activity. The shaking did cause many geysers to change their activity, but that's sort of like shaking the plumbing in an old house. Those geysers have very fragile plumbing systems, and so the shaking can cause those to break down and cause many geysers to change their behavior. But in terms of eruptive activity, distant earthquakes, local earthquakes, nuclear blasts, all be devastating events, but would not trigger Yellowstone erupt. That's one of the most common misconceptions about the system. Okay, now let's talk about what we observed in Yellowstone in terms of earthquake and deformation and geyser activity over the past month.
The University of Utah seismograph stations, which is responsible for operation and monitoring of the Yellowstone seismic network, recorded 168 earthquakes in the region during the month of February. Now, the largest was a magnitude 2.9 that was about 11 miles to the northeast of West Yellowstone. That was part of a swarm of 76 events that occurred between February 4th and February 11th. You also see there was a swarm just to the east of there near Grizzly Lake, 48 events that occurred during the month of February. And this is actually part of ongoing seismicity. There's been small earthquake swarms occurring here since last summer. And this is not too surprising. The area between Hebgen Lake and the north central part of Yellowstone National Park is the most seismically active area in the region. And then you can see for the rest of the month, earthquakes scattered about the region. This is all pretty normal for Yellowstone. This represents a background state of activity in terms of earthquakes. We also didn't see really significant changes in the deformation style at Yellowstone. This is the last 2 years of vertical deformation at the White Lake GPS station. It's on the east side of the caldera on the Sour Creek Resurgent Dome. Each one of these blue dots is a day of data. Downward trends indicate subsidence, the ground going down, and upward trends indicate uplift. Now, over the last 2 years, the gradual trend has been one of subsidence by a few centimeters, about an inch or two per year, and this has been ongoing since 2015, and it's interrupted in the summer months by a pause or even a little bit of uplift. This is due to snowmelt that percolates down into the ground, and the ground sort of soaks it up like a sponge, and then once the summer's over, we get that return to subsidence. So we've seen that subsidence going on over the last few months since the end of last summer. The same story is true on the west side of the caldera near Old Faithful on the Mallard Lake Resurgent Dome. Overall subsidence of a few centimeters, an inch or two per year, interrupted in the summer months by a slight amount of uplift, but then return to that subsidence as soon as the summer ends. There hasn't been much deformation in the area of Norris Geyser Basin. Again, there's that summer 2022 bit of uplift, but then really just a slight amount of subsidence since then. There are these occasional drops that look like really dramatic subsidence. You can see one right here in December 21 to January of 22, and then several in late 2022, early 2023. These are winter storms that covered the GPS antenna in snow and ice And that causes this apparent subsidence, but once that snow and ice goes away, the station returns to normal. And finally, looking at the world's tallest geyser, Steamboat Geyser in Norris Geyser Basin. This is the temperature in the outflow channel. You can see in about February 10th or so, we start seeing fluctuations in temperature. That's due to minor eruptive activity at the geyser. Often we see minors before a major eruption. There were 2 major eruptions in January. But unfortunately, we lost power to the station starting in mid-February. We also are not able to access the seismic station in the area since late February. So we can't verify whether or not any eruptions occurred using those data sets. Power is very fickle in that particular area since it's in the central part of Yellowstone. They get an awful lot of snow. But we do have a stream gauge that monitors all water flow out of the Norris Geyser Basin area, and that actually records steamboat eruptions. This is the height of the water going past the stream gauge from January 1st to the end of February. And there are 2 spikes right here in early January and in late January, and these are associated with Steamboat Geyser eruptions. If we zoom in on that early January spike, you can see it sticks out like a sore thumb. Really, really obvious spike due to steamboat eruptions. Now, we haven't seen a similar kind of spike in February as these 2 in January. These other spikes that are a bit broader are associated with precipitation, rain and snow that cause the water flow to increase. It's possible that there is a steamboat eruption perhaps hidden in this spike here. That's something we'll be able to test once we reestablish communications with our monitoring stations in Steamboat and able to download the data that were recorded during the second half of February.
Well, that does it for the March 1st update. Now remember, if you have any questions at all, feel free to email us anytime. Our email address is yvowebteam, all one word, @usgs.gov. Happy birthday to Yellowstone National Park. Stay safe, stay healthy, and we'll see you next month. Bye-bye.